So we're going to use the graphing calculator to try and investigate if there's a linear correlation between the cost of pizza and the cost of a subway token in New York City. The first thing we have to do is we have to input the data. So to do that on our graphing calculator, in fact, let me see if I can do it a different way. Let's do it here because this, might take too long. All right, we'll do it with this. So to input your data, you're first going to go to Stat and then press Enter because you want to edit a couple columns of data. Now, if there's some stuff here already, you can go to the top, press the Clear key, and Enter. Clear and Enter to clear out this old data. Now I've got all that data cleared out. I want to enter in pizza cost in column 1 and then subway cost in column 2. So that data is going to be 0.15, 0.35, 1, 1.25, 1.75, 2, 2.25, 2.3, and 2.75. Oops, didn't like something. Let's see. Oh, must not have hit Enter key. So the last one's 2.3 and 2.75. For the next column, the subway cost, that'd be 0.15, 0.35, 1, 1.35, 1.5, 2, 2.25, 2.5, and 2.75. Now to graph this, I'll give you kind of a brief show on how to graph this. We're going to first of all adjust the size of our window. Now on the x-axis, I want to go from, say, 0 up to 3. I'll actually go a little bit farther for reasons that I won't bother you with. So we'll go from 0 to 4.5. And on the y-axis, I want to go from 0 to 3. And I'll set that up. And then to actually graph this, my statistical data, I'm going to do a statistical plot. So second, and then y equals. You press Enter, and you can turn this plot on. Your column is in, your data is in L1 and L2. You can adjust those. You can put them in different columns if you want by hitting second, and then these 6 keys will allow you to pick whatever column you've got. And let's graph it. Oops. Go to, there's some equations here that I want to get rid of in my y equals. Now I can graph it, and I get a graph that looks like this. Does there look like there's a linear correlation there? Yeah, it looks pretty good. Looks like the price of the subway tokens marches up in more or less lockstep with the cost of pizza. Is it a perfect linear relationship? Am I going to get r equals 1 when I look at this? No, not. Let's figure out what that linear relationship is. So to do that, you go to Stat, then over to Test. Probably easiest to scroll up. And, I didn't go over to Test. There we go. Scroll up, and you want a linear regression t-test. There's going to be a lot of stuff that spews out of this, but we want 2 things. We want R, and we want the p-value. So when I calculate this, there's my value of R, 0.9917. Probably more or less what we expected, right? We expected something close to 1. And if you scroll down a little further, let's see, now maybe it's up. Here we go. I think I might have made a typo with some of the data I put in because I got a different p-value last time. Are you? Yeah. The reason you're getting a 0 for a p-value is because there's a little bit more to this p-value than meets the eye. So the p-value there really is in scientific notation. So the p-value there is 8.38 times 10 to the negative 8. And what that means is it's 7 zeros followed by 838. Now, with StatDisk, I think it's going to give you maybe 4 or 5 digits, and then it's just going to round it from there. And even rounding it, it still rounds to 0. So that's a great question. I'm glad you're keeping up with me on that one. Let's finish this hypothesis test. We're going to test rho equals 0 versus rho not equals 0. That is a linear correlation. Does it matter what alpha is? This is going to be smaller than any alpha that you can reasonably come up with. So if we're good there, we entered our data. Let's look at the p-value. P-value tells us what about our null hypothesis? Or, excuse me, our p-value, let me write that down, 0.00000000838. So step 5, what's that telling us to do with the null hypothesis? Reject, right? And that's a really small p-value. You're not going to get that by accident. So reject H0. Now our original claim, kind of like the last one, testing if there is a linear relationship, is this one. So we can kind of follow the same path here that we did with the previous one in writing our conclusion. Does the original claim contain the condition of equality? No. Did we reject? Yes. So we're here. Let's just state our conclusion in words. The sample data support the claim that there is a linear relationship between the cost of pizza and the price of a subway token. Sample data support the claim that there is a linear relationship between the cost of pizza, and it's really a slice of pizza, but cost of a slice of pizza and the cost of a subway token. Subway fare. So there's a correlation there. Now, a good follow-up question is that correlation also a causation? What do you think? Do you think that the New York Transit Authority says, oh, I see the price of pizza going up, we better raise our fares, right? Probably not. Right? The price of the fares went up, people raise the price of pizza? Okay, could be true. But it's probably just that prices go up in general, right? You've got inflation. In fact, the author included the CPI. Does anyone know what the CPI stands for? Consumer Price Index. And it's showing you what's happening to the price of goods and services. So as the price of goods and services go up, both of these are just a reflection of that. So this is just a correlation, it's not a causation. So what we'll look at next is how do you establish a causal relationship. But for now, I think we're pretty good on this one. Any questions on that part there, number 15? Okay. For homework, try 1 through 19.